Hi, this is Charlie, and this is the intro video for Chapter 8 on tectonics. And I wanted to do a Google Earth intro video because this is the first chapter that we're talking about endogenic forces. Endo refers to inside. Endogenic forces are the forces that drive plate tectonics and create volcanoes and create earthquakes and create mountains, and they're driven by Earth's internal heat. So 95% of everything we talk about in this class is going to be a function of latitude, right? The tropics are hot, the poles are cold. If we look across, let's just start with Africa. Africa is the best for latitude. So we've got tropical rainforest, we've got tropical monsoon, tropical savanna, steppe, and full-on desert. And then going south, it's the same pattern with savanna, going into steppe, and then desert. So if I turn off that, you can see that there's pretty good agreement. Here, right where the ITCZ is parked year-round, we've got tropical rainforest, and then it gets drier up to the desert. If I zoom in just a little bit more. So again, we've got rainforest and monsoon, savanna, and steppe, and desert. And if I turn it off, you can see that going from, it's pretty obvious, right? There's this core of rainforest, and then we've got monsoon and savanna. And then the savanna, this region right in here, where this is desert, this is savanna. The region in between is steppe, where the precip is less than potet. Up here in the desert, precip is less than half of potet. So pretty good example of the role of latitude, but everything we're going to talk about in Chapter 8 has to do with being driven by Earth's internal heat. So let's take a look at the plate boundaries. So all the lines that you're seeing now, the red lines are divergent, where the two plates are coming apart. This plate is moving to the west, this plate is moving to the east. Iceland right on top of a divergent boundary. Iceland is getting stretched apart. New material keeps coming up. And then there are yellow lines, and the yellow lines are convergent boundaries. So this is the Pacific plate. Here's the North American plate. The Pacific plate is pretty much moving this way. It's moving northward into the North American plate. And when the Pacific plate runs into the North American plate, the Pacific plate actually gets stuffed down, gets forced down into the hotter regions of Earth, where that plate melts and bubbles back up to the surface, leaving us with volcanoes. So convergent boundaries associated with melting crust and volcanoes. Same thing over here. This is the Juan de Fuca plate. This is the yellow, again, a convergent boundary where the plates are coming together. Red is a divergent boundary. So this part is moving to the east. This part is moving to the west. The Juan de Fuca plate moving underneath the North American plate, and then giving rise to the Cascadian volcanoes. So here are the Cascades, all the way from Mount Lassen, all the way up to Mount St. Helens, Mount Rainier, Mount Baker, Mount Cook. All the volcanoes of Oregon and Washington and Northern California are caused by the subducting Juan de Fuca plate. So outstanding agreement between volcanoes and convergent plate boundaries, convergent plate boundaries, convergent. Oh, I love the Scotia plate. It's so cute. It's just this little tiny plate with this little chain of volcanoes. If we look at Africa, this is the Rift Valley. So Africa is getting stretched apart. This part of the African plate is moving that way. This part is moving that way. And so you've got this chain of volcanoes down the Rift Valley of Africa. Some places where there's convergence, you don't have volcanoes. So the Indian plate has been moving into the Eurasian plate for about 40 million years. But here we have the Australian plate moving into the Eurasian plate. The Australian plate is subducting because the Australian plate is more dense. Here we've got the Pacific plate subducting under the North American plate. The North American plate is continental crust, so it is less dense. The Pacific Plate is made of oceanic crust, so it's more dense, so it sinks under the continental crust. But here, both plates are made of continental crust. So nobody subducts, nobody's melting, so you don't get a chain of volcanoes with the Indian-Eurasian collision. You get the Himalayas, you get the Hindu Kush, you get the Karakorums, you get these amazing, amazing, amazing folded mountains. The Zagros Crush Zone here in Iran, these amazing folded mountains. Other places where tectonics results in amazing features, the Rishiat Dome in the desert of Mauritania, this huge bullseye-shaped geologic feature. It's like 30 miles across. And for a long time, researchers thought it was caused by impact of, for example, a large meteor, but turns out it's just been lifted up and worn away, revealing these concentric rings. What else do we have? San Andreas Fault, our favorite fault running up California. So here we've got the San Andreas, and if I turn it around, running up the Gulf of California, which is then splitting apart. This is on the Pacific Plate. This is moving towards Alaska. There's areas like the Carrizo Plain. You can see the trace of the fault through here, right in through there, right in through here. Like, wait, what? Why is... Oh, because this is on the Pacific Plate. This is on the North American Plate. In fact, there's an amazing volcano, the Neenah Volcanoes. One half of it is up by Santa Cruz at Pinnacles National Monument, and the other half is down here in Southern California. So one half of the volcano split about 23 million years ago. And so the south part is down here and the north part is up here because they're on different sides of the plate. If we look at Tomales Bay, there's Tomales Bay. Here's Point Reyes. Point Reyes is on the Pacific Plate, so it's moving towards Alaska. This is on the North American Plate. Tomales Bay is in fact right over the San Andreas Fault. The San Andreas Fault moves right through Point Reyes. So this little chunk of crust is actually on a totally different plate than this. This is moving at about 6 centimeters a year towards Alaska. So if we came back in a couple million years, Point Reyes would be farther up the coast. That's going to be amazing. That might be about it. Let's see. We looked at volcanoes. The crust is getting stretched apart through the basin and range. You've got convergent boundaries here, resulting in the crust melting and bubbling back up. Yeah, that's it for this part of the Google Earth intro. I hope you enjoy this chapter. It is way more concrete. It is way more hands-on. There's way more stuff that you look at and go, oh, right. Pacific Plate, North American Plate, oceanic crust, 3 grams per cubic centimeter, continental crust, 2.7 grams per cubic centimeter. Anyway, I hope you enjoy this chapter.